Okay, I think let's start. So, have you guys done any question on binary search? The list we have provided, or have any of you have any tried any question? No. Okay. And what happened with the last question which we were doing? Have anyone tried to read the discussion on anything to understand how to do that question? The rotated one. Yes, no.
No, sir.
No. Okay. Do anyone remember question? Do you guys remember the question which we were doing at that?
It was related to some water capacity and like left and right comparing heights, lowest one
No,
and
no. I am talking about yesterday.
okay, sorry, I was absent yesterday.
Yeah.
Uh, like minimum and rotated sorted array, right?
Yes. Yes. Okay. Let me share my screen. If you guys remember, this is where we were. So, just for those who have not joined yesterday class, so initially we were given this array 1, 2, 3, 4, 5. Sorry, not this one. It was 0, 2, 3, 4, 5, 8. Okay. So after we rotate the array, the new array which we got in the question was this. Do anyone have the question link? The one which I shared at the end? Okay. Okay. Yeah, so this was the question. And we were discussing how we will apply the binary search here. Okay. So yesterday what we were doing at the end, initially um, we started with the binary search. So the low for the binary in the binary search would be 0, which means it will be pointing to this. And the high would be pointing to this. And when we tried to find out the mid, it came out to the second index, which is what? The second index is what? 0, 1, 2, which was 5. If I'm not wrong, 0, 1, 2. Okay, yes. It was 5. Okay. Then what we did was, now in if the array was sorted as it is given in the first way, and if array was sorted like this, there was no rotation done, then we know when to go to left and when to go to right. But if the array is rotated, it's not going to be as straightforward as the way we are doing it in the if it is simply sorted. For example, let's say, in this one, we got to know that our first mid is 5, which is this one. Now, how we will in binary search at every iteration, what we try to do is we try to reduce our search space. We try to take some decision. Hey, do we want to go to the left half or do we want to go to the right half? This is the way we are trying to reduce the search area. Now here, since the array is sorted but rotated, how we will find it out whether to go to left or whether to go to right? This is the only question which we try to answer, which we are trying to answer here. Do anyone remember like what we did yesterday for this?
Uh, I guess we compared uh, array of low with array of mid,
Mhm.
and if it is less than, then we shifted high to mid -1, right?
So you mean we went to left or we went to right? Instead of saying high, I mean the better to think, hey, we have gone to the left or right. Okay, so let's say here. What is the low here? It is 3 for now. What is the high here? It is this one. Okay. If we compare this 5 with this 3, what we got to know that hey, from whatever elements are there from 3 to 5, definitely they are in the increasing form. That means they are sorted. So if we are looking to go to left, there is a chance that we can get the smaller number. Okay. This is one of the observation. With comparing this, we can say that hey, we should go to left. We should wait. With this observation, um, comparing 3 and 5, comparing 3 and 5, we decided that we will should go to left half. Now let's compare the other one. Okay, if we compare 5 with 2, what are we getting from this one? There is that, hey, there is a chance that the smaller element can also exist in the right also. Yes or no? Because 2 is lesser than 5 already. So by comparing this, again we thought that hey, we can even go to right also. We can go to right also. Now we are confused here. Should we go to left or should we go to right? So for this, what we did is we compared this 3 with this 2. We compared the low and high. If we compare with low and high, what information we are getting with this comparison? What we are getting is that hey, in the right, the elements are smaller than the left because this 2 is lesser than this 3. So that's how we made a decision that hey, we should go to right. Final. Go to right. Is this clear to everyone?
Yes. So like on every iteration, are we going to make 3 comparisons?
Not required every time, but here you saw no that hey, that we got confused when we compare mid to low and high. We got confused because both, according to both of that, they are saying opposite direction. Okay. Now to make it finite that hey, where to go, we use this third comparison, which is low and high. In some of the places, you will not require it. For example, if the array is something like this, 0, 2, and 3, you will compare with this, you will get to know, hey, go to left. If you compare this with this, are you getting that go to right? No. So straight away go to left. We don't even need the third comparison.
Okay.
Okay. Is it, is this is the only, this is a single traversal only, by the way. Single while loop. This entire transaction which you have done, this entire comparison is a part of one loop only. If it is clear to everyone, then we will move on to the next iteration. Since no one said no, just to make sure it is yes. Okay. Since no one said no, let's move on to the next phase then. Now we got to know that we need to go to where? We need to go to right. Okay. We need to go to where? Right. So if we are going to go right, what will be our new low and what will be our high? This is the first iteration values. Since we are going to right, high will not change at all. So high is going to stay 5. And low will be mid plus 1. What is mid? Mid is 2. Last mid was 2. So low will be mid plus 1, which is 3. Correct? So now our search area is from 3 to 5. And what is 3 to 5? 0, 1, 2, 3, 4, 5. Okay, 802. So now we only need to search 802. So let's move on to this one. Let's only discuss about the 802, 8, 0, and 2. Low is here and high is here. What will be the new mid value?
Zero, sir.
Low. Okay, yeah, correct. Low value will be 0 and index is going to be what? We always say index. 4. You are correct. 3 plus 5 is 8. 8 by 2 is 4. So, and fourth value is 0, correct. Okay. So, yeah, it's correct. The value will be equivalent to 0. Now, we again need to start doing those comparisons. Compare 8 with 0. What we are getting from this? Okay. If we are not, let's focus. Let's discuss the next one. From this, it is very clear that whatever element that more that all whatever element are there in the right, they are always going to be bigger than the 0. If we compare this, when we compared mid with high, this is a typical binary search. Now, there is nothing I'm like saying different with from the normal search. So if the mid is lesser than the high, then it is clear. Then from mid to high, all the elements are lesser than the 0. Whatever elements are there after this 0, they are going to be lesser only. Sorry, they are going to be higher only. But in the left, we don't have this assurity. There is a chance that we can have more lesser element in the left. I know this is a little bit confusing. So let me do it this way. Let me do it again. We will see the code, then it will become more clear. Okay. So we compared this 0 with 2. We got to know if we go to right half, we are going to get we are going to get a higher value. And what we are looking for is finding the minimum value. But when we are comparing this 0 with 8, we are not getting this assurity. You know why? Because I mean, there can be a chance that there are elements between -1, 2, and all those things. Again, this also depends on how the array is rotated. But for now, you can say we don't have the assurity that, hey, in the left, we are not going to find the lower array. That's why we are going to go the left. This question is little bit tricky because it depends on how the array is rotated also. the condition which we have just talked about, that A when to go to right, when to go to left, depends on how the array is rotated. If you change the way the array is rotated, for example, this was the array. Initially, you was rotating it like this. But if you start rotating it this way, it will become, the conditions are going to get changed. Is this part clear to everyone? We are going to see the code, so don't worry. We will cover every condition there. But this was the basic thing about this, basically. That we need to make, there are three comparisons which you can make. Either you will compare mid with low, either you can compare mid with high, or you can compare low to high. Based on these three comparisons, you have to decide when to go to left and when to go to right. Now tell me, is it clear or not? We are going to see the code, so things will become more clear. Yes, no.
Sir,
Any,
again repeat one time.
which part? Which part?
The last part. Actually, I
Last?
cannot understand this question.
You are not able to understand the question or the solution?
The solution.
Okay. Just a second.
Sir, so we are basically splitting the array into two parts and then comparing, taking the middle and comparing the left and right.
Can you come again?
We are splitting the array into two parts and taking the middle and comparing left and right, like which one is low and which one is high.
Not exactly. Were you there in the last lecture? Have you gone through the initial binary search?
No, I was absent last lecture.
Yeah, so you should have gone through recording, and maybe you can go through recording today. But it's not exactly like the way you are seeing. So what we do in binary search, we try to keep reducing our search space by half. So initially we were considering that hey, we need to search element from 0 to 6 index. Now we find a mid, and then we make a decision. Hey, should we check the left half only, or should we check the right half only? For example, if you remember an example of dictionary, now your
Yes,
name start with S, so there is no point of going through the words which starts before S. Like for example, PQRS. So before S, R letter comes. So in dictionary, everything is sorted. So all the words which start with R will come before should. So is there any point to search your word in the left half of the book
no,
before
no,
S?
no,
No.
right point.
So this is the like basic idea about the binary search.
Okay, yes, sir.
I'm also pasting the code. Let's try to go through it again. Just one second. Yeah. Let's do this question by through some other way. The first thing which I told you, maybe it looks like a little bit more complex. Let's try to do it some other way. This is going to be more easier way to do. I would suggest you guys to take few minutes and try to read this one. I hope this is going to make much more sense because this is more easier solution. Here, instead of comparing low and high, you are just using mid and mid plus one to compare. You are saying, hey, if my next value is greater than the current value, then we know the arrays that bigger elements are there in the right, something like that. We are using that method here. Is anyone able to understand what they are trying to do here? in this code. This is not the one which we just did. This is more simpler way of solving this problem, I would say.
Here in num, mid is equal to nums mid plus 1. Like we are checking for a number bigger than mid value and trying to return it. And the next line after this, next iteration, we are checking for a number lesser than the mid value.
Correct.
And then we are trying to yes, and in the beginning we have done right minus left. Like we were checking it for the left side, mid is equal to left plus right minus left divided by 2. Uh, from there it has come over here. Like after that, uh, mid is greater than uh,
Wait,
mid.
let me explain the crux of this solution.
Okay.
Initially, let's say the array was just the code here. Yes. So initially, let's say the array was 1, 2, 3, 4, 5. Now the after rotation array becomes something like this. What they are trying to find out is the irregularity or a inflection point or a change which is unexpected, which should not have been there for the sorted array. What is that unusual thing which is here? It is this thing. No?
Yes.
If the array is sorted in the increasing order, then next element should be always greater than the previous element. If it is not there, you know what does that mean? That means is that this element is the starting of that sorted array. This is what it means. So let's try to do more different example. 2, 4, 6, 10, 12. I am rotating it by 10, 12, 2, 4. Where are you see any inflection point or any irregularity? It is here. And the smallest element is wherever you will see a irregularity, that means because that is the starting point of the the sorted array. The sorted array was this. When you rotated it, you move the 2 after 12. And definitely that is something not usually correct in the sorted array. After 12, it should come 13, 14, 15, but not 2. What does that signifies is that, hey, the array was rotated for sure it is given in the question, but the smallest element was 2. If the array was sorted without any rotation, then 2 was going to be at the first location. So that's why here, if you see this loop, what they check? Consider that the let's say consider that what I'm trying to is just 1 second. Yes. Yeah. So what they are doing here is nums mid greater than nums mid plus 1. What does that mean is if we are seeing a decreasing format, let's say mid is 5 and mid plus 1 is
6.
1.
But
I'm
there
talking
is
about the values. These are the values.
Oh.
Okay. The mid value is 5 and mid plus 1 value is what? 1. So
One.
this condition is true.
Yes.
So that's why they returned this nums mid plus 1, which is let's move to the next condition. Here, if I write it in another way, this is, let's say, decreasing. Wherever you see a decreasing pattern, decreasing. decreasing. Now, as you can clearly see, array was increasing 3, 4, 5, but then there was a decrement. After 5, it was 1 there. So there you find out your solution. What we are doing in the next thing, again, it's the same thing actually. Here, let's say your mid was let's say your mid was equivalent to 1. Mid value, let's say, sorry. Mid value was equivalent to what? 1.
1.
What will be mid minus 1 value? Before 1, what is there? 5.
5.
So this condition is true that 5 is greater than 1. So you again find out the same thing. 1 is the answer. Again, same thing. Decrement process, decreasing array. Let's come to the next. Here is that they are doing the same thing which I was telling you. Okay. They are not using low, but they are using nums 0. 0 means the first element. If they think that middle element is greater than 0, definitely the same thing which I told you. If mid is greater than the 0th element, that means all the elements from 0 to mid are in increasing format. Okay. So that's why they did this. Left is equivalent to mid plus 1. Otherwise, they are doing right plus 1. First thing is, are you able to understand these first two conditions? I know this is going to be a little bit complex in the starting, but yeah.
Yes.
What about others? The first two conditions should be clear, very clear, because they are straightforward. What about others? If it is clear to everyone, I will move on.
Clear, sir.
Which one? What part is not clear? Okay, sorry. You said clear. Sorry, I thought that. Okay. Just okay. It's clear to everyone. Okay then. Now this one. Are you guys able to understand the last one? This condition. Try to read this line. Also try to read the comment which is already given.
So 5 is being compared to num at index 0. So that will
Yes.
be 3, like 5 is compared with 3.
Correct. Is this clear to everyone? I mean, have anyone got these two conditions? The last two conditions?
The left in the code is like left for 5. Uh, that will be 4. 4 is equal to mid plus 1. Uh, is it comparing 4 with mid plus 1? Mid plus 1 will be 1. So 4 is being compared with 1.
No, it's too much confusing. Wait. Let me try to erase this and rewrite. Okay, otherwise it's getting confused what you're saying. Wait. I will write all the values of mid and low, then we can do it in the middle. Okay, this is. So this was the given array, we rotated it, and the final array which we got was 3, 4, 5,
1, 2.
1, 2. Let me write their indexes so that we don't get confused. 0. Wait, not this issue. Um, 0, 1, 2, 3, 4. Okay, this is basically the index.
Yes.
Now, let's say that we have initial low equivalent to 3. When I'm saying 3, consider it is a number directly. Okay, they are the values actually, and high is at 2, and mid will be where 5.
5.
Yeah, 5. Yeah. Now try to do it. Now they are saying that hey, if mid is greater than low, then we will not check the left part anymore. If this mid is greater than the low, we are not going to check the left part, we are going to check the right part.
Yes, sir.
Is this clear to everyone why they are doing it?
Why we while not be checking the left part?
Checking the left part, I will show you a code. Because they already did it here. Going to left means if we have already compared that mid is greater than the 0th element, then we know from 0 to mid all the elements are already sorted, they are increasing forward. So the lowest value could have been what? 0 itself. Okay, first thing is that, and that they are already checking on line number 27, 28, 29. Clear now? Yes or no?
Yes, sir.
Okay. And similarly, the else condition, this one, I mean, if that is not true, automatically you are always saying that we will always go to the left.
Yes, sir.
That's it. So that's a straightforward thing. So if you are not going to left, right, that means you have to go to left. Or vice versa, you can do it reverse also. But this is the thing. But here, one more thing which I want to tell you guys. If the array is rotated in a different way, then things will get changed here. So make sure while you are solving the question, you get it like what. Make sure the questions you are getting, you need to really solve it. Otherwise, you will not be able to understand the concept just based on the class. Until and unless you are writing the code, you are practicing it, it will not work out. If instead of rotating the array this way, what if we rotate it some other way? 1, 2, 3, 4, 5. We were rotating it this way. Now let's say I start rotating it another way. It will become what? 5.
4, 5, 1, 2.
Correct. 4, 5, 1, 2, 3. Do you think this code can still hold the answers? I mean, this code can still solve this problem.
Now the mid value will be 1 and we'll have to check it differently.
Let's talk about simple thing. Here we are saying that the array needs to be decreasing. This is decreasing.
Yes.
Yes. So this condition can be still used. This is still correct. You can still use this exact code condition. Okay.
Yes.
Is this correct? This can this be still used? Yes. The concept is again same. When you see a decreasing pair, you get the answer. the decreasing pair is this. After 5, if an element is coming up which is lesser than that, that means you have already found out the answer. What about these two conditions? Do we need to change anything here actually? That's the major question. Are you guys there? That's the last two condition needs to be changed. Just apply it, na simple thing. Apply it. And if you see you are able to get the answer, then we can discuss more. Do you think we are able to get the answer? Let's say mid value is 1. You compare 1 with 4. 1 is definitely not greater than 4. It will go to the else. And else is saying go to the left half, which is because right mid minus half. Will you be able to find the answer in the left half? No, not at all. Try to do this at your home and let's tell me later on that with us this condition still is true or not. Can we apply the same code if we rotate the array in a different way? Yes or no? It can be or it cannot be. I mean, you need to tell me that. By this is considered as your homework because we need to start more from this question. Hopefully, the core concept of this question is clear. Basically, while you are doing the binary search, what you are getting from the binary search concept is at every iteration you decrease the search space by 2. Now, in different question, you will use different loop, different if-else conditions to find it out whether to go to left and whether to go to right. Binary search concept is only about base concept is that hey, every time you decrease your search space by 2, and you need to decide at every iteration whether to go to left or whether to go to right. This is the basic concept of the binary search, nothing else. Everything else is based on the question which you need to find it out basically that hey, how I will decide when to go to left, hey, how I will decide when to go to right. Clear?
Yes, sir.
Okay. Okay, so have you got the questions for binary search already on the platform, or have any of you even checked? Yes. Okay. Have any of you have tried to do any question from that? And if you have any questions from that, like any questions you tried, you were not able to understand, or you did not, you was not able to understand the solution.
Uh, like we can try this one capacity to ship packages within 2 days.
Can you send the link?
Sure.
After this, we will start a new concept. Is my screen visible? The capacity to ship package within D-Days is clearly visible to everyone. Yes, okay. Try to read out this question. Mute yourself, guys. So the question is, we have a conveyor belt as package that must be shipped from one port to another within day. Consider that you need to move some packages from one place to another, and there is a belt. For example, you must have seen the elevators in the metro stations where you just tapped in and it automatically go from one location to another. Consider it like a belt. It's that way. Now we are given an array where they are saying that you have multiple packages, boxes, whatever you say, and each box have a different weight, which is already given in the array, which is weights array. It says first box have a 1 kg weight, then 2 kg weight, then 3 kg weight. Different boxes have different weights. They are saying each day they load the ship with packages on the conveyor belt in the order given by the weights. We may not load more than the maximum weight capacity. Okay. What they are doing is, sorry, what they are saying is they are already given the order of the weight. They are already given the order of the boxes which they need to load on the belt. Now, if you guys have, let's say, seen the lift or the belt, there is something written always in the lift that there is a maximum load which it can handle. Like, hey, if only 8 people can be there in the lift. Similar to that, this belt is also having some maximum capacity that, hey, this belt cannot move the more than 400 kgs from one location to another location in one go. Okay, so this is the max. This is what we say is the maximum capacity of belt. What do we mean by maximum capacity of the belt? Is how much weight it can handle in a single point of time when it is moving from one location, when it is shipping the product or boxes from one location to another. Now they are saying they load the weights from the given array one by one. For example, they will load 1, 2, 3. It will be always sequential, basically consecutive, like the arrays. They cannot say, hey, let's add the 5, then 6, then 7. No, they will always have to start from beginning. They will have to first load 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8. So this is how they are going to do it. They will take 1, they will take 2, they will take 3, they will take 4. Now they will get to know that, hey, the belt does not have the capacity to hold 5 also. So let's first ship this one first. This is the way they are going to ship the product from one place to another place. Now you need to find it out that now you know that there is going to be amount which is going to take to move the product from one location to another location. Okay, as they mentioned here, each day we ship the package on the conveyor belt. So you can consider you can only move the belt per day. Basically, if you are moving the product from one location to another location, you can only do it once per day. It cannot be like, hey, load it once, let the belt move all the product from one location to another, and then come it back and do it again. No. In one day, you can only do this process once. Simple thing. Now, they are asking that you have 5 days to ship all the products from one location to another location. What should be the minimum capacity of the belt to make sure that all the products can be shipped from one location to another location? Hopefully the explanation is clear to everyone. Question is clear to everyone? Okay. What about others? Sudhi, Sahil, Vipin.
Yes, sir.
Okay. Okay. Now, how should we solve this problem? What if I say that in your school time, do you remember you must have done something that, hey, let's consider let x is equals to 10 and then try to see if the question is possible or not. If you remember that same analogy which we did with the equation. Hey, try 1, try 2, try 3, try 4. Can't we do it here? We can say, hey, let's think that the minimum weight of the belt can be 1. Try if it is possible to ship all the weights in 5 days. Then try 2. Then try 3 weight. Then try 4 weight. Then try 5 weight. Now you see this is a linear search. Can't we do is by using the binary search? Just do it. This is how we are going to solve this problem. First, you consider that, hey, maximum weight of the belt is going to be 1. Then check, is it possible even to ship all the products within the given days? If it is, then we found out the answer. Then not, then you try 2, then you try 3, then you try 4. Whenever you hit the condition that, hey, we are able to ship it within the given days, we got the answer. This is linear search which we are doing. One by one, one by one, one by one, one by one. But should not we use binary search here? Low can be 0 and high can be the sum of all the product. I have a question, simple question. If I want to ship the entire consignment in one day, then what is going to be the answer? Just tell me, guys. This is the very simplest question of this entire question. If I
I
want to
don't
ship,
think so it is possible because capacity of 15 is given. So we'll have to split
wait,
and then
this is no, this is the output, na? This is what you are saying. I am saying days is equivalent to 1. Consider this days is equivalent to 1. Okay, wait, let me change the question for you. The question is this. Now tell me how much time it is going to. Sorry, what should be the max? What can be the max belt capacity? Sorry, belt capacity.
Yeah,
This is the easiest question.
sum of it.
Sum of all weights. Correct? Is it
Yeah.
clear to everyone why we are
yes,
saying? Okay, great. So what I'm trying to say, consider low equivalent to 0, high equivalent to this sum of all weights. Find mid equal to low plus high divided by 2. Check if mid weight is enough to ship product from one place within D days, within given D days. Okay, this is the thing you check. If yes, move to left half in hope of finding more lesser weight, lesser capacity of, of pet. If no, move to right half. Note, if you remember, we use ANS variable in some last questions to find first index or last index. This is like that. Tell me this is clear or not.
Low 0, like it
Low
doesn't
one, low
and
one, low one.
can have like we can have it as
Yeah,
we
what we can do, sorry,
can
we can have the minimum, we can have the maximum of all, something like that. Minimum or maximum of all. Low can be equivalent to, should be equivalent to,
it should be
I would
maximum
say,
because at least there would be one day. At that day I have to ship that maximum capacity as well.
correct, correct. Yes. Even by the way, even if you keep the even if you keep the 0, you will still get the answer. But yeah, we will be wasting some iteration. So don't worry about it. But yeah, correct way is to say, as Sandeep mentioned, that low should be the maximum fall rate because we can't say that hey, break the product and then move on. One product have a capacity, sorry, have a weight of 10 kg. So definitely belt needs to have at least that. So that's why we are using max of all weight and then high sum of all weights. That's and then we are following the same process. If you guys remember, we have done that first index of a number. That's why I did that question because that was the basic concept to the every question which you are going to do with balance. That is the only basic concept which you will use. Everything else is going to remain same. With that first index of a number, last index of a number, we are using the same concept here also. Even if we found out the answer, we are still going to go to the left half to say that hey, there can be, for example, you can say, hey, the belt can have a capacity of 100 and we are able to ship all the products within 5 days. But there is a chance now that belt can have even a capacity of 95 and it is still able to move all the products within the given days. So why we are not trying to find it? The question says we need to find the least capacity, not just the capacity. So that's why even if we found the answer, we are still going to the left half and then if you guys remember, we will be using in code, we will be using ANS variable to keep storing the last answer whenever we were able to successfully ship the products. Do you guys want me to write the code for this? I don't think so, but if you say, I will write it.
Like from binary search, like we got some idea, like from binary search you can solve, like, but what will be the brute force for this? Like we'll be picking 5 unique elements every time.
Can you come again?
Like what will be the brute force for this if we don't want to solve this via
If
binary?
the brute force would be start from first way. Say, hey, let's check if you can ship the product with a capacity of 1 weight, then 2 weight, then 3 weight, then 4 weight, then 5 weight, then 6 weight, then 7 weight, then 8 weight, then 9 weight. Whenever you hit, whenever you saw any value which is successfully working, you just return the answer, because it's like that first bad version. If you remember, is in first bad version we could have used linear search checking, that whenever you see first call which returns to is bad version API call returns to, we got the answer. Similarly, you could have done it here. You could have said, hey, let's try 1, let's try 2, let's try 3, let's try 4, and whenever you hit a true, just return it. Then you don't even need to think twice. That could have been the brute force approach. Anyone else? Do you want me to write the code? Yes, no. Do you guys want me to write the code, or should we move on to the next concept? Okay. Okay. Someone have raised the hand. Mm, yes, you have raised the hand. I mean, do you want to say something? Okay. Should be okay. Should be. I would suggest you to first check the previous session, because you have not taken the last lecture. Even if I code it, it's like doing from the zero. So try to go to the previous lecture in the next session. If you don't get it, I can explain you there. It will only take 4 5 minutes. Okay, but I would suggest you to go to the previous lecture.
Yes, sir.
Okay.
So the
Any
concept is same, like taking the mid value and then comparing.
yes. Concept is going
Oh,
to be the same.
yes, sir.
Okay. Any other question from binary search which you want to discuss? Anyone? Sandeep, Vipin, Sahil? If you guys have tried some other questions also. No? Okay. How many of you know about stack and queue?
Sir, step follow LIFO concept last in first of and LIFO first.
What is LIFO, by the way?
सर लास्ट इन फर्स्ट आउट मतलब जो स्टेप है लास्ट में इंसर्ट करेंगे वो पहले अब बाहर आएगा
And what is queue?
फिर वो फर्स्ट इन फर्स्ट आउट जो पहले जाएगा वो पहले बाहर आएगा.
Okay. Anything else about them?
Both are linear data structures.
Sorry?
Both are linear data structures.
Not exactly, but okay, I'll still take it. I mean, it depends on your implementation, how you are implementing both of the things, actually.
Even if
So,
we
Star
implement
would be linear, but Q is not, because DQ and is also there.
no. It depends on the implementation. If let's say you are implementing stack is made on the basic structures. Basic structures, when I say, it can be either array or it can be either a linked list. Okay.
Yeah.
So, and let's say, for example, you can say, hey, I can, you can say it's a linear structure if the stack is made by using the array. But what if I say that stack is implemented using linked list? Is it still going to be counted as linear data structure? You may from the front see it as a linear, but in the backend it is not. It may not be.
But we can also have circular queues.
No, let's only talk about the basic concept. Even in the circular queues also, by the way, can be handled with the double list. It's not a big deal at all, frankly.
Yes.
Okay. So you may say they are linear, but it depends on the implementation.
Like
Okay.
even if it is linked list, then also it's linear only. Like so we bifurcate these things only if something has branch, then only it will be considered as non-linear, right?
So
Link,
you
yeah,
go ahead. So are you saying linear linked list is a linear data structure? I
correct.
think we had the discussion. Okay. Okay. And array is also the linear data structure.
Right. Anything which do not have branches is linear. Like by the time linked list is don't have any branches, it's linear. And as soon as it starts taking branches, then it's non-linear or maybe tree.
Correct. 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 So we can say they are linear, as you mentioned, if they don't have any branches, but they are not contiguous basically.
Yes.
I was talking about contiguous, but I used the word linear. So when I was saying that it's not linear, I meant they are not contiguous basically. As you said something, you are correct. Basically, stack and queues both are also linear data sets. What else? Like what are the other things about stack and queue?
Complexities might
Um, Actually, they are not in. I but okay. Anything else? By the way, can you make a stack by using the queue?
Using queue. Uh,
Yes.
yes, yes.
How? How we can make it?
I guess no.
I guess yes.
How like the entry point and exit point should be one for stack, but for queue,
You will use two queues.
okay, okay, then yeah, then
I
okay.
never said you can. I never said you use only single queue. Okay. So by using two queues, you can make it work. You can create a stack. Now, can you create a queue by using stack?
Yeah, I guess using two stacks will just keep popping from one stack to another.
No, I
Okay.
think so because in stack, first in and last out is there. So that and in queue, first in first out is there. So
Yeah, that's a.
it will get piled up. So uh, that's why.
You are correct. You are correct. You are correct. Actually, the concept which the way you are thinking is correct, but there is a small trick there to make it work out. Actually, okay, we will see it how it actually works. Don't worry about it. Okay, let's me first start with the basics just to make sure everyone knows what is stack and queue. Let's say just a basic example which you are going to read in every book. You must have seen like while you are keeping the plates on the floor. Let's say there is a floor. You keep a plate here, then another plate goes up, then another plate goes up, then another plate goes up. So this is what we call the stack. So if you are going to pick any plate, from where you will pick it? Are you going to pick it from here or are you going to pick it from here? Definitely you are going to pick
So
it from here. from the top. So this is what we call the stack. That hey, whatever is going in the last is going to be the first one to come out. But in queue, it is something like this. You added this split, you added this split, you added this split. Let's say you are in the queue. Simple best example for this one is the queue. Sorry, you must have already heard the word queue. यार हम line में लगे हुए हैं अभी. If you are, let's say, going into the bank for demonetization, you have seen people, let's say, people are in the line. Let's say there is a bank here. कि हम line में लगे हुए हैं. There is a 1% there, then 2%, then 3%, then 4%, then 5%. Who will be the first person who will enter the bank? This person, no?
First with
Then
the
this person. Yes. So this is first in, first out. Whosoever is first in the line will be the first who will go out. And here in the stack, whosoever is in the last in the line will be the first one to get outside. स्टैक में जो सबसे लास्ट में जाएगा वो सबसे पहले बाहर आएगा. क्यू में जो सबसे पहले अंदर जाएगा वही सबसे पहले बाहर. सीधा सीधा सीधा. Clear to everyone?
yes, sir.
Yes, sir.
Now there are 3 operations in both these things. Let's talk about first this stack. Push, pop, and peek. Push means adding a new element to the stack. Let's say this is a stack. You pushed one element. You pushed one here. Now, if you want to push another element to the stack, you will call the function called push 2. So it will push 2 here. Now, if you call this function, which is called pop, that hey, pop. So whatever is on the top of the stack, it will remove that element to the out. So now this will be removed from the stack. Now, what is peek? Hey, check what is the element, what is the top element in the stack. What is the top element in the current stack?
1,
And now what is the top element in the current stack?
3.
So peek will always return this, whatever is on the top of the stack. Let's talk about the queue. Push, pop, and front. Can you guys tell me what this is going to do? Let's say this is a queue. Can anyone explain me these 3 operations of queue? So simple thing, as in the stack, push was adding an element to the stack. This push in the queue also will add the element to the queue. Let's say push 1. So hey, 1 is here. Pop. Whatever is the first element in the queue, pop it. That means remove it. Cut it up. Front. Hey, what is the first element in the queue? Front element in the queue. Hey, it is 1 if we don't remove it actually. Okay, so this is the thing. Is it clear to everyone?
Yes, sir.
Yes, sir.
Oh, okay. Now let's move on to the next question. Make a stack by using two. Make stack by using queue. Can anyone tell me how we are going to make it? We have already discussed, so you guys need to tell me.
So we'll be using two queues. So whenever a new element come to stack, we will pop all the elements from the first queue to the second.
Okay, let's make a that thing then. You are saying we
Uh,
will use two queues. Wait. So let's say
DQ,
this is the Q1. Q1. This is Q2. Okay. The stack operations are this. These are the stack operations. Push 5, push 3, push 1. Pop. Pop should return. I will write it separately. Peak and pop again. So I will also mention their results. Nothing will return, nothing will return. This will return 1. This will return 3. Okay. This will not return, remove basically. Sorry. Remove, remove. These are going to be addition. Add, add. Now tell me how you are going to use 2Q for these stack operations. Simple things.
Like for push, we'll continue to insert in the queue. Like let's push 5, then 3, then 1.
One, wait. Q1 or Q2? Just need to
Any
specify.
any queue, like maybe Q1, let's say Q1.
Okay. We pushed 5, then
Then
we pushed
3,
3.
then 1. Now my push, sorry, now my pop should return the, like it should delete 1, right?
Mhm.
Okay. So, but like queue, we cannot extract 1 directly. So what I'll do, I'll throw 5 and 3 in the next queue. So they will maintain their order, like the stack order.
Then
3 would be on top. Now I will delete 1 from Q1.
what do we mean by delete?
Delete me basically pop, like,
Okay. We will pop it.
so now Q1 is empty and Q2 is kind of preserving stack, like the top is 3 and 5. Although like so let's try to okay, what's the next operation? It's peak.
Wait, I have one more question. How you are going to push the element from Q1 to Q2?
So from Q1 we can only extract from FIFO manner, right? 5 will go first, then 3 will go
Now,
next.
what are the operations which you will use over Q?
Operations in the
What
sense.
are the exact steps? Like push, pop, yeah, I will push, pull from Q, push to Q2, those operations.
Yeah, pop from Q1, push to Q2.
Are you sure? Pop will remove it. Pop does not return anything.
Then do peak first and
Correct.
then
So first step would be peak. Peak would give you what?
5.
5. Second step would be push 5.
Correct.
What would be the next step?
Pop 5 because now we don't need 5 in Q1.
Pop 5. What is the next step?
Then repeat the same process for 3. Peak, push, pop.
Okay, done. So now this is going to look like this. Then what? What is the next thing now? We have solved the problem till this part. Now next.
Yeah, now we need to peek in the stack, which should return me 3.
Okay.
Okay. And again, we have to do the same thing. Like we have to throw elements from Q2 to Q1 to get the
Okay.
top.
What should be
Third,
tell
I
me the
got 3.
exact stuff. Okay, let's say first I've inserted 5, then what? 5 has went here, then what?
Then I'll check the size of Q2. If it's 1 only, then that element needs to be picked. Like that's the last element of the stack.
Okay, then you peaked it, then what?
Then again, push it to Q1.
Okay,
Again, pop. Okay.
then we have done this one also.
Then again, move 5 to Q1 and like the same thing which we did previously, peak, push, pop. Not pop for 5. Like the pop should only. Yeah, we need to do pop as well. Yeah. So
Okay, there is a one mistake in your entire process. I would explain it. What is it? This process is clear to everyone. What we are doing.
Yes, sir.
Okay. Can anyone specify what was the wrong in the process? Conceptually, it was correct, but while you will code it, you will see some problem. Not a problem, but I mean, you would be doing some unnecessary. Yeah. Actually, even that is fine, but okay. Here, whatever we have done till now, it's fine. But in some of the code, in some of the, I wouldn't say it is wrong. You can add some extra condition, it will work out. So in some of the solution, you will see while we moved all the elements from Q1 to Q2, na, just for popping and peaking, some people will do it to get the answer, and then they will move all the elements from Q2 to Q1 back.
okay, we'll again move it back.
Yeah, it's not required. As I said, you can always check whether Q1 is empty or Q2 is empty, and then you can always use the. Uh, but the issue is going to be in the coding part actually. How you are going to code it, because you are going to write the specific steps. Na? That hey, push Q1, push it to Q2, push it to Q1, push it to Q2, push it to Q1. But in your case, Q1 and Q2, like this juggling of moving the elements from one index to another index, the combination is changing every time.
Yeah, like we can change the reference of Q1 and Q2 instead of popping
It's
and
not as it's not uh, as straightforward. You will have to end up using the I would say patterns and all those things. But you will generally see what will people do is we will move the all the elements from Q2 to Q1 back. We will always consider that Q1 is the is the entity which is holding all the elements. And whenever we want to find something, we use Q2 as a temporary queue and then try to do it. While you try to code it, you will get the answer why we are doing it. But the thing which you mentioned is correct. I'm not denying it that hey, instead of moving all the elements from Q2 to Q1, I can change the referencing of Q1 and Q2 both, but you will end up using two pointers which are pointing to the queue addresses and all that blah 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 thing. It is possible, but what I'm trying to say is in the code which you might see from others, you will not see all these things. They will simply move back all the elements back to the same question thing basically. This was just for your knowledge. So when you try to go to other solutions, you will get it more like why I tried to say that. Okay. Any question from this track and queue? No? Okay. I'll give you another question. Consider that there's a question where they are saying that hey, they are saying there are two operations. add element, remove element, return minimum. These are the three operations. Add element is going to saying that, hey, add this element to the data structure, whatever you have created. Basically, they are asking you add this element. Remove element, simple thing, you remove that element. Okay. This is like a stack, you can say. There is a stack where they are saying that, hey, add the element, and when they say remove, you always remove the last element and you do it inside. But in the return minimum, they are asking to return the minimum of all the arrays which are there. Return minimum, in return minimum, you always need to return the minimum of all the values, whatever is there in your data structure. For example, let's say it was 2, 3, 5, 0. So now minimum is what? 0. But let's say they ask to remove the element. So last element is what? 0, you remove it. Now they will again ask what is minimum. Hey, minimum is 2. Again they ask to remove, is minimum is getting changed? No, it's still 2. So this is the thing which you are going to do in this question. Now tell me how you are going to solve this question. And we will take 5 minutes break. You guys can think about it, like how you're going to do it. I will come back at 10:30. Anyone, how we can solve this problem?
So one question, we can only add and delete from the last, right?
So when the question says remove element, they are saying remove the last element. Now it's on you what data structure you use, how you do it. But when we are calling remove element, the question says remove the last element which was added. That is what they want. Now, if you want to use tag, so use tag. If you want to use array, whatever, you can use anything. But this
So
is what they want.
we can do one thing, we can keep a minimum variable and
Okay.
never at the time of insertion I got uh, any variable which is less than my current minimum, I'll swap it with the first
There
position.
is a issue with that concept. Let's say the minimum which you are holding in your current minimum, it also got removed when the remove element was called. Then what will be your next minimum value? Because your current minimum value is gone.
So current minimum value. So yeah, that's the question. We can remove from anywhere, like, or we can only remove from the last.
When question calls remove element, they say remove the last element which was added. The question called add, hey add 2, hey add 3, hey add 4, hey add 5, done. Then it calls minimum again and again, whatever. Then it calls remove element. What was the last element which was added to the data? It was 5, so remove 5. That's it. That's what it means.
While adding any element, we can initialize it to be a minimum. And then I think
That is fine, but the issue is that remove element. When the code calls say remove the element, then what you will do?
the last element added in the stack will be
Will be
removed.
removed. Okay.
Yes.
So is it not going to impact the minimum? It is.
Uh, yes. So we'll check like is it the minimum or it's the maximum? Like we'll
Let's
put
say it
a
is the minimum. No, it is the minimum which is getting removed. Then what?
and return minimum, like it will give the value.
Can we keep some sorted type of structure apart from our current data structure?
How? Okay. So let's say the minimum value. Now what after every add call and after every remove call? By the way, we have already kind of used that concept. So yeah, tell me that. What if I say you can use stack here?
Stack of minimums.
Whatever value are we going to remove, we'll check.
No,
Like,
no. Use stack for holding the minimum value in every condition. What I meant is, let's do it. We will create two stack. What are the addition called? 2, 3, 5, 3, 2 stacks. S1, this is the min stack. I mean, I'm just naming it min stack. It does not mean anything at all. Hey, push 2. Okay, I push 2. Whenever you are adding element, you will always compare it with the minimum. This is the minimum. Initially, minimum will be maximum value, anything max, you can say. What is the current minimum after adding a new value? It is 2. So push this 2 also in the minimum. Next, add 3. Okay, add 3. Is our minimum value is going to get changed? No. So still add the main value again, 2. Add 5. Okay, hey, does we got new minimum? No, again add 2. Now, hey, let's say let's remove it. Remove 5. We removed it. We removed this also. Hey, what is the current minimum? Again 2. Okay, let's forget about that operation. Let's do it at going there. Let's add 0. Hey, does the minimum got changed? Yes, it has got changed. So 0. Now let's play the removal game. Hey, remove last element. Remove. Sorry, let's not remove it. Let's first get the what is the current minimum? What is the current minimum?
0.
0. So you can return the answer as 0 here. Now you remove the last element. You removed it. You removed it. What is the current minimum? 2.
Two.
Again remove the last element. Again remove the element. What is the current minimum?
Still 2.
Again remove the last element. Again remove the last element. What is the current minimum? Done.
Like why we are removing every time from the min stack, like even if my element is not equal to minimum. So when we remove 5, why I remove 2 from the min stack? Like
The
only if
stack
is
is
not
this minimum stack is parallel to the S1 stack. So
but
each
do we need to insert these many twos? Like can't we just keep single 2? Like until unless my 2 won't be deleted from S1. Like I won't delete 2 from min stack as well.
there is an issue with that concept. But
Duplicate.
if there can duplicates, yes.
Okay. Yeah, then it's fine.
Everyone have got this? Seems yes. Okay. Let's talk about another way. Although another way is not, I'm not sure should I went ahead with it, but let's still let's go with it. Someone said that hey, we can keep the array sorted. Let's talk about that concept. What was the issue with that concept? What if I say let's not use stack? Can we solve it in another way? We can solve it. I'm not sure should I mention it or not. One of the way can be ordered map. I know we have not discussed this. The hash we have not discussed the hash map yet or the hash. One way can be ordered map. Simplest way. What can be other way of doing it? I will tell you. You create an array. Whenever you get an element, you check what is the correct place to add it here by using the binary search. Let's say existing element are this. Okay, you get one. If the array is empty, then we don't need to do anything. We will just add one. Now, let's say you got two. Then you, by using binary search, you try to find out where we need to insert to. We got to know we need to insert it at this. Now you get zero. Now you again use binary search to find it out where to place this zero to make keep the arrays out. We got to know we need to add it at the beginning. So you can add it. Now, what is the problem with this approach, the one which we just discussed?
Every time we need to shift multiple elements.
That can be easily handled by linked list. I don't see any issue there. But yeah, I see issue because by using binary search on linked list can be a lot of help. That can be one of the problem. What is the other problem? Okay, that can be the one of the problem that hey, we are going to make a shift and shift will require okay go on. Okay, let's not talk about the time complexity. What is the other thing with where we will face the issues?
Duplicates.
What is the issue in duplicates?
Like
You're just adding it now, so you will just find the place where to add it and add it. What about removal? In removal also we will have to do the same thing. By using binary search, we will spot the element. And while we are removing it, again we will have to shift actually. Are you getting it? Same thing the same issue which you were having it with the addition. To get the return, you will always say, to get the minimum, you will always say array zero, simple thing. So getting the minimum is the easiest thing here, but addition and removal is the issue. Can we somehow solve it? The only issue which we are seeing with the addition and removal is that if we try to insert any element in between the array, then we will have to shift all the elements which are in the right. Is there any way to fix it? One way we could have thought of is linked list, but the issue with the linked list is it can be pretty hard to apply binary search on linked list actually. Can we apply? Okay, let's think about it. How we will apply binary search on linked list if we need to apply tomorrow? Let's say the way we apply binary search is indexes. There is no index in the linked list. So even if we want to reach to the mid, then we will have to traverse all the elements one by one. So it is too much active. But is there any other way? One way would be which we have already discussed, which I should not mention actually, but so we can use ordered map, which always automatically do it for us. Is there any other way to do this? The problem is whenever we are inserting a new element, we are required to shift all the elements which are in the right. Correct. What can be the better way to do this? Anyone? Is there any solution at all? First thing is that. Okay, no, there is nothing with the basic knowledge which we have till now, which we have discussed. We can't solve that problem by that way. There are some ways, but they are not. We can't discuss it now because we have not done much on that one. Okay, hopefully this question is clear to everyone. Like these are the things. Like these are the ways you need to start thinking about the problem. Whenever you are doing any problem, you will encounter many issues. You will try to solve those issues by one solution, and then you will see, hey, there is another issue with that solution. Then you will try to fix. That's how you do solve the DSA problem. If this is clear to everyone, should we move on?
Yeah.
Hmm.
So like
How,
somehow we like although like we haven't studied it, but somehow can we use priority queue type of thing in this?
how you will remove in priority queue? The issue would be others can ignore this part since we have not discussed priority queue. So in priority queue, you will always, let's say, you can always get the minimum. Great, no issue. Addition is also going to be fine. But how the removal will work? Think about it. Fine. How you will do the removal?
All right.
There's no way to do the removal uh, in that actually. I can actually I can still fix this issue. Okay, there is a hack here. While whenever you are pushing any element to the priority queue, instead of just pushing the value, you will also insert the index. Okay. Whenever the remove is getting called that hey remove that array, that remove that value, you need to know you will store that value in the hash map. Whenever you pop the value from the heap, you will check whether hey, is this element is in my hash map and is the count greater than 1. If it is greater than 1, everything is going fine. If it is not greater than 1, that means you need to remove that element from the heap and return the next minimum value from the heap. I can't go more deep into where it could be waste for everyone's time. But this is one of the hack which you can use by in the priority queue. Yes, it can be solved in the priority queue. Okay.
Okay. Yeah.
Yeah. One other thing which I think I forgot to do for that is how we will create queue with stack. You need to create queue with stacks. If it
Against.
is clear, yeah,
Yeah.
just one thing. If it is clear to everyone, I don't want to waste the time here. If it is clear to everyone, I would move on. So I don't want to go into the discussion because we have already discussed a very deep explanation. Do anyone need any explanation how we are doing this? I'll check the chat if no one says we need, then we will move on. Because this is completely similar to the one which we have already solved, just little bit here and there. And don't worry, you are going to get the LeetCode question of this also, so eventually you are going to do it. But there is no new conceptual learning or new angle of learning in this question. But since I mentioned it in the beginning, I thought of just to bring it up. It seems not till now, let's move on then. Do you guys remember in your school time, you must have done something called, I even forgot, bonus? What was that formula? Bogmatic, the one which you used to solve with the arithmetic formula that hey, first solve plus, then solve negative. What we used to call? Board mass field. Yes, I know.
Yes, bracket and uh, of is there, then division is there,
Yes, board
and
mass field. Actually, before,
multiplication, addition, and subtraction.
correct. Stack is related to this also. I will not go here for now because it can little bit quite complex. I will solve another problem. Please someone note this down so we can like later on discuss this. Let's talk about parentheses. So everyone know what is parentheses now? Like these are the parentheses. Close bracket and open bracket. Do you guys know what is balanced bracket? Balanced equation. Sorry, balanced brackets, let's say. Yes or no, straightforward. We don't have that much time. We are only up to 30 minutes.
Yes.
So balanced bracket means whenever if there is any opening bracket, there should be a closing bracket also. Okay. And one more thing. There can't be more than I mean it's okay. This. Is this parenthesis balanced or not? Say yes, no.
Yes.
Yes. Okay. Fine. Is this balanced?
No.
Okay. Is this balanced?
No.
Do everyone know why first one is yes and other two are no? If yes, we will move on to the question directly.
There is
Seems
an
yes.
open brackets are lesser in number and close than the
Correct,
closing
correct,
bracket.
correct. When going from left to right, if you see it at any index that hey, number of opening brackets are lesser than the number of closing brackets, so it's invalid. Because if you remember in your 9th, 12th, you used to have seen this equation: 2 + 4 into 4, something like this. What you used to do, you used to first solve these parentheses and then move on to the. I mean, that was the basic concept. But the concept of balance bracket is number of open brackets needs to be equivalent to the number of closed brackets. Plus, the most important thing is when you are going from left to right, at every index, number of open bracket should be either greater than the number of closed brackets or equivalent to the closed brackets. That's it. That's the only condition. Now the question is, you are given a string. Okay, let's forget about string. You are given an array, something like this. Why I'm not saying this thing? Because we have not done anything on the string, so I'm trying to ignore it. But again, it's same as a string. So this is given an array. Now you can consider it something like this. You need to tell whether the given array contains a balance parenthesis or not. Simple thing. How you will find it out.
Here we can use stack.
But about others,
Yes, sir. We use a stack.
and how we will use the stack here?
Sir, create a stack and insert first. मतलब सर पहले हम एक स्टैक क्रिएट करेंगे, उसमें फर्स्ट जो ब्रैकेट उसे इंसर्ट कराएंगे, अगर उसका एक क्लोजिंग ब्रैकेट मिल जा रहा है तो उसे पॉप करा देंगे उस और एंड पॉप वैल्यू वी आर यूजिंग।
What if when you are trying to pop it is empty? You said that कि जब भी ओपन ब्रैकेट मिलेगा हम पुश कर देंगे स्टैक में, और क्लोज मिलेगा तो हम पॉप
तब
कर
पॉप
देंगे.
करा लेंगे। यस सर।
ठीक है. व्हाट इफ जब आप पॉप कर रहे हो तब स्टैक एम्प्टी है, तब क्या करोगे?
देन सर देन
Not balanced.
Yeah, uh, then the given array or the given parentheses are not balanced, so you will return false. Otherwise, if everything is going fine, you will return. Simple thing. Okay. Is it clear to everyone?
Yes, sir.
Okay. I think I forgot one thing today, which was about coding the thing. Let me bring the code also. Okay, I'm pasting the code. Let's see the code also, just to make sure the declaration part and all those things. Okay, done. Now this one is that. Okay, done. So see the code, the basic code about this Q and like how to define them and all that. So this is for C++. Sharing the link if you want to check it on your flat type or whatever. So this is for C++. This is how you define the stack. If you are pushing the integers in the stack, you use int. If you are pushing the character, then you use char. If you are pushing the double or float, based on that you change the structures. And these are the operations for pushing, for popping, and it was not peak actually. It was top for stack. And yeah, for Q it is front as we have discussed. And in Java, this is how we store it. This is how we declare it in Java. The operations how. Actually, in Java we call it peak. Yeah. Okay.
So in Java, we always use linked list to implement queue. Why not array or something else?
You can use the array, but linked list is better. In stack, the issue with the even with the stack, I mean, you think about yourself that in the array, if you keep like whenever you define the array, as we have talked in the beginning, whenever you define the array, you always need to specify the what memory. That hey, I am going to store the four memory, four, five elements, six elements, seven elements, eight elements, nine elements. In linked list, you don't need to do. The way operations are, they are of stack and queue. Do you think you really even need the array? We only need the address of first and last element, and linked list you can give us both of them. You can do the same thing by the way with stack also. In stack, we always need to reach to previous element, so you can use doubly stack, or you can use kind of a reverse linked list. I mean, when you are pushing the element, instead of pushing it at the end, you always push it at the head. So you can always move that to the next to get the last. Like we can there is a workaround there too. You can use linked list with the stack also. That's what I was saying. The implementation can be different for different internal implementation. When I say implementation, is the code clear to everyone? The C++ one and the Java one. This is just a basic code I just showed you. Otherwise, there was nothing in Java.
Yes, clear.
Sure. Okay. Yeah, I think for today, I don't think so. We have anything. I didn't started sliding with me today because I thought that binary search is already maybe too heavy for you guys since the first that rotated one specifically because of that. Otherwise, in the next session, we are going to start sketching more newer concepts. Make sure you are solving the problem. Otherwise, in the upcoming days, you will face multiple problems. Because whatever we have done till now, they are going to be get used in the newer concept which you are going to learn. It will be like while using one concept, you will end up using multiple concepts which you have already learned. So make sure like you are spending enough time on solving the problem. Do anyone have any question for me? I will share the list of the question which you need to do from binary search I have already done. Okay. For stack and queue, I need to do. Let me note it down once. Yeah, I will provide that list of the question which you need to do. You have entire week this time. Monday, Tuesday, Wednesday, Thursday, Friday, whatever. Even if you do 3 questions a day, which is I think is less since you are in college only. So, but by the next session, you should have at least done 15 questions. 5 to 15, straightforward math. So start spending more time on solving the questions. That's the only way to learn the DSL way. Just the theory and the concept will not be able to work out. You need to write as much as code you can, then only you will get it. While you will code, you will face multiple issues. If you have already started coding, then you will get to know those. Otherwise, once you start them, you will see them. Any questions from me, from any one of you, or about anything?
Sir, which book to follow for theory?
There is no theory in DSA, Algo, frankly. You need to, whatever I'm covering in the session, I'm mostly covering, there's no as such theory, frankly. If there is binary search, they will explain you what is binary search, which you are already discussing in the session. At the end, if it is about solving the questions, if you are facing the issues with the questions which I'm giving, start with the easy questions. You can go to the lead code, say easy questions, get a list of the easy questions, then filter it by binary search, filter it by other concept. That's how you need to go. There is no theory as such in DSA. It's about practice. It's a simple math. If you remember in your school time, do you used to read any theory for solving the math question? No. You were solving maths question to solve more maths question. Simple and straightforward from that. So there is no theory as such. Even I can provide you theory, but it's not. It's going to be worthless. We are already covering those things. There can be some few corner cases, which but that will eventually come when you start solving the questions.
Yes, sir.
Anything else? Anyone? No? Okay. Any feedback or anything? Any improvement you guys think we should do from next session? Any change which you think can be helpful for all of us to get a better understanding of the things and to maybe make a better progress and make more progress? Anyone? Seems no. Okay. We can wind up the today's
Sir,
session. I
can
think.
we like communicate in group itself, like what was taught and if any
Yeah, yeah,
doubt?
yeah. You guys can.
Oh,
There must be already a Facebook group. No, sorry, WhatsApp group. No? Or
yes,
even if
sir.
you go to the platform, even on platform there is something. I saw there was a group. There's a discussion section where you
Okay,
can go and chat. There is a channel also, I think. Yeah, there is a
okay,
channel also where you can where you each other can discuss, and maybe you can create a Facebook group or WhatsApp group, whatever you want to create. You can definitely go for it. No
okay.
issue with that.
Yes.
For those who don't know, so I'm just also sending a link. This is the, as also Sandeep said. I mean, yeah, he said hello everyone. So in the chat itself, so I'm just sending a link for everyone also. This is the link. So you guys can even either chat there or maybe if you want to create a different group, whatever you want to do, you can just go for it. We don't have any issue with that. Anything else?